Hi again from Dr. S's Random Math Lair. This video is just a supplement to problem 9, and it's about the distance formula in the xy plane. Recall that in part C of problem 9, I left you to verify the distance between the focus and a point on the directrix of a particular parabola, using that same exact distance formula. This topic is usually covered in courses involving plane geometry and algebra, at the high school freshman or sophomore level. A bit later, we shall see that the distance formula in the xy plane can be derived from the Pythagorean theorem for a right triangle. Now let's introduce the distance formula in the xy plane. Consider a point A, given by the coordinates x1, y1, and a point B, given by the coordinates x2, y2, in the xy plane. Denote the distance between A and B by dA, b. In the xy plane, the distance formula is then given by the equation dA, b equal to the square root of x2 minus x1 whole squared, plus y2 minus y1 whole squared. This means the distance between 2 points, A and B, in the xy plane, is the square root of the sum of the squares of the change in their x coordinates, and the change in their y coordinates. Let's make some important observations. The distance between any 2 points A and B, in the xy plane, is always positive. That's why the distance formula uses the positive square root. The distance between the 2 points A and B is clearly 0 if and only if A equals B. It should also be clear that the distance between the points A and B is equal to the distance between the 2 points in reverse, that is, from B to A. I encourage you to verify this fact using the distance formula in the xy plane, now that I've introduced it. A bit later, we shall derive the distance formula in the xy plane from the famous Pythagorean theorem, which we shall quickly go over next. Let's quickly review the Pythagorean theorem. Named after the ancient Greek philosopher and mathematician Pythagoras, the Pythagorean theorem states that a right triangle with base length A, height B, and hypotenuse length C, satisfies the equation A squared plus B squared equals C squared. The base and height of a right triangle are also often referred to as the legs of the right triangle, in this case of length A and B. Now let's derive the distance formula in the xy plane from the Pythagorean theorem. Let A, given by the point x1, y1, and B, given by the point x2, y2, be the endpoints of the hypotenuse of a right triangle, as in figure 1. The hypotenuse has length dA, b, that is, the distance between the points A and B. The right triangle's base has length x2 minus x1, and its height is y2 minus y1. Note that this is the change in x coordinates, and the change in y coordinates, respectively, as we travel from A to B, along the hypotenuse. Then by the Pythagorean theorem, we have that dA, b squared equals x2 minus x1 whole squared, plus y2 minus y1 whole squared. Taking the square root of both sides of this equation, we have the following, which we immediately recognize as the distance formula in the xy plane. As a bonus question, what are the coordinates of the point at the lower right corner of this right triangle, in figure 1? In a while, I will provide more details about this bonus question. Remember, this video is a supplement to problem 9, and is related to part C of that problem. Recall that for problem 9, part C asked us to find the standard form equation of the parabola with focus 2, -2, and directrix given by the equation y equal to 4. We observed that the point 2, 4, clearly lies on the directrix, and above the focus. We claimed that the distance from the focus to this point is 6. We shall verify this claim using the distance formula in the xy plane. So let F be the focus, and P be the point 2, 4, which we denote as x1, y1, and x2, y2, respectively. Also let dfp denote the distance between f and p. Then, using the distance formula, we eventually see that the distance between f and p is given by the positive square root of 36, which is 6. This verifies our claim from part C of problem 9. Here's a bit more about the bonus question related to figure 1. If interested, answer the bonus question as a comment below this video. Hint: the distance formula in the xy plane may help. The answer is quite straightforward, so give it your best shot. I will reveal the answer a few days later also in the comments below this video.